When most people think of black holes, they imagine a cosmic monster that swallows everything in its path, including light. However, there is a lesser-known counterpart to black holes called white holes that are theorized to be the exact opposite. While black holes are regions of space where gravity is so strong that nothing can escape, white holes are regions where nothing can enter. These hypothetical objects were first proposed by theoretical physicist John Wheeler in the 1950s, but they have yet to be directly observed. Despite this, the mere possibility of their existence has fascinated scientists for decades, and some believe that they could hold the key to unlocking some of the biggest mysteries of the universe. So let's take a closer look at what white holes are, how they were theorized, and what makes their discovery so exciting for scientists. Hello and welcome back for Mindful Moments, where we discover and explore the captivating realm of science, technology, conspiracies, and the universe. Before diving into this video, make sure to click on that red subscribe button and follow us on our journey in discovering and exploring more world mysteries, conspiracies, and scientific discoveries. Black holes are one of the most mysterious objects in the universe. They are a region of space where the gravitational pull is so strong that nothing can escape, not even light. Black holes form when a massive star dies and its core collapses on itself, creating a singularity. There are three types of black holes: primordial, stellar, and supermassive. Primordial black holes are thought to have formed after the Big Bang, while stellar black holes form when massive stars die and collapse. Supermassive black holes are found at the center of most galaxies, including our own Milky Way. Black holes are detected through their effect on nearby matter, such as stars or gas. When matter gets too close to a black hole, it is pulled in and heats up, emitting X-rays that can be detected by telescopes. White holes are the theoretical opposite of black holes. Although there is currently no observational evidence for their existence, unlike black holes, which pull everything in, white holes are thought to push matter away. They are a region of space where nothing can enter, only exit. According to theory, a white hole would have a structure similar to a black hole, with the singularity at the center and an event horizon surrounding it. However, instead of trapping everything inside, a white hole would spew out matter and energy. Objects can leave and interact with the outside world in a white hole, but nothing can enter the interior, which is disconnected from the past of the universe. According to James Bardeen, a black hole expert and professor emeritus at the University of Washington, it's more unsettling to have a singularity in the past that can influence everything in the outside world. Albert Einstein's field equations had a significant impact on physics when they were introduced in 1915. They not only described the force of gravity but also revolutionized our understanding of reality. Space and time, rather than being inflexible, bend and fold along with the mass of planets and stars. This realization led to a competition to determine how much abused space could withstand from drifting matter. Within a year, physicist and astronomer Carl Schwarzschild found the first precise solution to Einstein's equations, demonstrating how space-time curves around a single ball of mass. The solution included the seeds of a singularity, a spherical mass compressed to an infinitely dense point that constricts space so tightly that the area becomes separated from the rest of the universe, creating a no-man's land where the event horizon breaks the connection between cause and effect. Schwarzschild utilized Einstein's field equations to derive the equation of mass in empty spacetime, which is a mathematical representation of a black hole. He established an equation for a black hole that does not alter in size and has always existed. While white holes comply with general relativity and are mathematically valid, some scientists question their existence, claiming that they violate the second law of thermodynamics. Black holes excel at increasing space disorder, but white holes, which eject matter, violate this law. In 2006, NASA's Swift satellite detected a gamma-ray burst that lasted for 102 seconds. This observation was named GRB 060614, and it was located in a galaxy much closer than most gamma-ray bursts, only 1.6 billion light-years away. Its discovery baffled scientists because it didn't fit into any of the existing categories of gamma-ray bursts. Some scientists have suggested that GRB 060614 may be a white hole, the theoretical opposite of a black hole. White holes are hypothetical objects that are predicted by the mathematics of general relativity, just like black holes. While black holes are regions of space-time from which nothing can escape, white holes are regions from which nothing can enter. However, unlike black holes, there is no observational evidence for the existence of white holes. The idea that GRB 060614 could be a white hole is purely speculative, and there is no direct evidence to support it. However, if it were true, it would be an incredible discovery. White holes are believed to be the opposite of black holes, and they would represent a completely new type of object for scientists to study. If GRB 060614 is a white hole, it could give scientists new insights into nature of the universe, and it could help them better understand the relationship between space, time, and gravity. However, white holes are believed to not live out long. While GRB 060614 was only a short burst for almost 2 minutes, while general relativity describes white holes in theory, no one knows how one might actually form. A black hole cordons off its bit of space when a star collapses into a tiny volume, but playing this video backwards doesn't make physical sense. A violation of the statistical law demanding that the universe gets messier over time. A long-lived white hole, I think, is very unlikely, said Hal Haggard, a theoretical physicist at Bard College in New York. At one point, white holes were thought to be like wormholes, possible according to the math, but not realistic. However, in recent years, some scientists have revived the idea of white holes to find a solution for the death of black holes. Ever since Stephen Hawking realized in the 1970s that black holes leak energy, physicists have been debating how black holes could disappear when they lose energy. The question is, what happens to all the information of the matter they swallowed? The laws of general relativity say that this information cannot be released, and the laws of quantum mechanics prohibit its destruction. By explaining space as constructed from tiny Lego-style pieces. By using concepts from this idea, he and other scientists have outlined a situation in which a black hole becomes so tiny that it no longer adheres to the laws of physics that govern stars and billiard balls. At the subatomic level, randomness from quantum mechanics takes control, and the black hole may evolve into a white hole. How does a black hole die? We don't know. How is a white hole born? Maybe a white hole is the death of a black hole. The two questions join nicely, but you have to violate the general relativity equations in the passage from one to the other, Rovelli said. White holes are a fascinating and mysterious concept in the realm of astrophysics. Their hypothetical existence challenges our understanding of the universe and raises many questions that we may not yet have the answers to. The mere possibility of white holes suggests that our current scientific laws and theories may need to be re-evaluated or even rewritten entirely. The thought of such a discovery is thrilling for scientists and space enthusiasts alike, as it opens up a whole new realm of possibilities and potential breakthroughs in our understanding of the cosmos. It's an exciting time to be exploring the mysteries of the universe, and the concept of white holes is certainly one of the most intriguing discoveries yet to be made. That's it for our video on white holes. I hope you found it as fascinating as I did. It's always amazing to learn about new things and intriguing discoveries in the cosmos. And if you have any questions or comments, feel free to leave them below. And if you like this video, please give us a thumbs up and don't forget to hit that red subscribe button to encourage us in making more videos like these in the future. And if you have any mystery, scientific discoveries, or conspiracies you want to share, let us know in the comments below. We're Mindful Moments, dedicated to exploring the captivating realm of science, technology, conspiracies, and the universe. See you again in the next video.